Assalamu alaikum dear students. My name is ISHFAQ HAMEED. I am working as a lecturer in chemistry at BHSS TARATHPORA, Kupwara. Today my topic is mole concept in case of ions. We have already discussed what mole concept actually mean, and we have used this mole concept for atoms and then for molecules. Now we have to discuss what is the mole concept for ions. We first told you that one mole is equal to the number of atoms in 12 grams of carbon-12 isotope. And then we determined the number of atoms in 12 grams of carbon-12 isotope that came out to be equal to 6.023 into 10 raised to power 23 atoms. And then we decided to make this term equal to 1 mole. And then here I have written it here. 1 mole is equal to 6.023 into 10 raised to power 23 particles. And these particles can be atoms, ions, molecules, electrons, protons. Okay. Then 1 mole is equal to Avogadro's number of particles. In honor to Amedeo Avogadro, we kept this number equal to Avogadro's number. 6.023 into 10 raised to power 23 particles is equal to Avogadro's number, which we can show by writing simply n or n with subscript a. If we use this mole concept for ions, you know that ions are present in ionic compounds. And what actually are ions? Ions are cations and anions. Ionic compounds are made of cations and anions. There is an ionic bond between two oppositely charged ions. Cations are positively charged and anions are negatively charged. So it's by law that opposite charges attract. So there is a formation of force of attraction between these two oppositely charged ions, and this force of attraction is called the ionic bond. Then when we write the formula of ionic compound, it does not represent us a particular molecule. It does not represent its molecule because the ionic compounds are made up of ions. And the formula of an ionic compound represents ratio of constituents. When we write formula of ionic compound, it represents the ratio of cations to the anions. For example, for a single, I have taken an example of NaCl here. NaCl, this is a formula of our common salt, and NaCl here is called formula unit. It's a formula unit of a compound which is known as common salt. Then NaCl, when it gets broke down into ions in presence of an solution, when we make its solution, then it breaks into ions Na positive and Cl negative. And when we write NaCl, it means that Na positive and Cl negative are in the ratio of 1:1. And I have taken here second example of calcium chloride. It breaks into two ions, cation and anion, Ca dipositive plus 2 times Cl negative. And here its formula unit represents that cation and anion are in the ratio 1:2, and it's not a molecule, as I told you earlier. Then how much 1 mole of NaCl will weigh? If we will weigh 1 mole of NaCl or any ionic compound, what will be its weight? 1 mole of NaCl is equal to 6.023 into 10 raised to power 23 Na positive and Cl negative ions. And then it means that 6.023 into 10 raised to power 23 Na positive plus 6.023 into 10 raised to power 23 Cl negative. If we somehow determine the mass of 1 mole of Na positive ions and the mass of 1 mole of Cl negative ions, their sum will be equal to the mass of 1 mole of NaCl. And for this, to calculate this, we first should know the mass of 1 mole of Na positive and the mass of 1 mole of Cl negative. Here the mass of 1 mole of Na positive is equal to gram atomic mass of sodium, and in this case the mass of 1 mole of Cl negative is equal to gram atomic mass of chlorine. We know that gram atomic mass of sodium is 22 grams and gram atomic mass of chlorine is 35.5, making a total of 57.5 grams. This means that 1 mole of NaCl, when we weigh it, it will be equal to 57.5 grams. Or we can also say that if we take 57.5 grams of NaCl, it will contain 6.023 into 10 raised to power 23 NaCl ions. And this mass here is called gram formula mass. As we use the term gram atomic mass for atoms, gram molecular mass for molecules, and for ions we use term gram formula mass. Then we can define gram formula mass like gram formula mass is the mass of 6.023 into 10 raised to power 23 formula units of an ionic compound expressed in grams. Gram formula mass is the mass of 6.023 into 10 raised to power 23 formula units of an ionic compound expressed in grams. We have to express the mass in grams. That mass is called the gram formula mass of an ionic compound. Now we are going to apply the mole concept for gaseous molecules. We have determined from Avogadro's hypothesis that 1 gram molecular mass at standard temperature pressure or normal temperature pressure occupies a volume of 22.4 liters, and this volume, which is occupied by 1 gram molecular mass at standard temperature pressure or normal temperature pressure by every gas, is called gram molecular volume or molar volume. What does standard temperature pressure or normal temperature pressure mean? It means the measurements are to be determined at temperature should be equal to 273 Kelvin or 0 degrees Celsius, and pressure should be equal to 1 atmosphere or 760 mm of Hg. 1 gram molecular mass is nothing but a 1 mole of anything, and here we are talking about gaseous molecules. How much 1 mole of a gaseous molecule weighs? I have taken an example of carbon dioxide and ammonia here. 1 mole of carbon dioxide or 44 grams of carbon dioxide at standard temperature pressure or normal temperature pressure occupies a volume of 22.4 liters. So we have to determine the volume occupied by any gas at this temperature and at this pressure. We have to calculate, we have to determine, we have to measure the volume at these fixed temperature and pressure. And for same is the case with ammonia. 1 mole of ammonia or 17 grams of ammonia at standard temperature and pressure or normal temperature and pressure occupies a volume of 22.4 liters or 22,400 ml. This 44 grams of carbon dioxide is the gram at molecular mass of carbon dioxide, and 17 grams of ammonia is the gram molecular mass of ammonia. Okay, then number of molecules in 1 ml of any gas at normal temperature pressure, temperature 273 Kelvin or 0 degree Celsius, and pressure at this very instant should be equal to 1 atmosphere or 760 mm of Hg, is equal to 2.68 into 10 raised to power 19. These much molecules will be present in 1 ml of any gas at normal temperature and pressure. and this number is called a Loschmidt's number. And then I have concluded the mole concept here. 1 mole in terms of volume is equal to 22.4 liters at normal temperature pressure or standard temperature pressure for 1 gram molecular mass of any gas. And in terms of number of particles, 1 mole is equal to 6.023 into 10 raised to power 23 particles. And these particles, as I told you earlier, can be atoms, ions, electrons, protons, molecules. And in terms of mass, for atoms, mass of 1 mole of atoms is equal to gram atomic mass of that element. And the mass of 1 mole of molecules is equal to gram molecular mass of that substance, because we are having molecules of elements and we are having also molecules of compounds. So the mass of 1 mole of molecules is equal to gram molecular mass of that substance, whether it is the molecule of element or whether it is the molecule of compound. For ions, the mass of 1 mole of ionic compound or formula unit is equal to gram formula mass of that ionic compound, which we have calculated in this few minutes before. We have calculated it very well what actually gram formula mass of any ionic compound mean.